Now, I'd like to take a couple of lessons out very early on here to give you a sense of what's going on with a raw image, how the mechanics of a raw image out of a digital camera actually work. Now, this is quite technical information. If you're not interested in technical stuff, fine. Go ahead and skip these next two lessons. If you are interested, and I find this very helpful, by the way, to know this information, then stick with me. In this exercise, we're going to take a look at how digital cameras capture images in general, whether they're raw or not raw. And then in the next exercise, we'll see how Camera Raw interprets that information and creates the full color image that you see. Now, for starters here, I've got this image open. It's called mosaicsensor.psd, and it is available to those of you who are premium members or who have the CD. It's inside the O1 Raw Beginnings folder that's inside your exercise files folder. And basically, here's what we're looking at. We're looking at a magnified detail from the actual image sensor, the chip that's inside of your digital camera, which might be a CCD or it might be a CMOS chip. Doesn't really matter at this point. All that matters is you got this little dinky microchip that's inside the camera, and it's covered with these teeny little sensors. So the word sensor is kind of confusing, by the way. It stands for both the chip and the little dinky, tiny, almost microscopic little dots that are on that chip that capture the individual pixels of information inside of the digital photograph. So we're looking in very, very magnified view of these little sensors that are on the chip. And each one of these sensors is responsible for picking up a single pixel of detail. So if you have an 8 megapixel digital camera, for example, then you've got 8 million of these teeny little gray things, all right? These little sort of rounded squares that are on the microchip. And this is mostly the way they look. This obviously isn't a photograph that we're looking at. This is an illustration that I mocked up here. But this is roughly how these image sensors look. All right, so what's going on is the digital camera, these image sensors that are on the chip, are really only capable of picking up luminance information, just the lightness information. They can't record color on their own. They just record luminance values. In order to generate the color, there has to be a color filtering system applied to these chips, which is also called striping. Sometimes you'll hear it called striping. And in order to see what this striping looks like, go up to the layer comps palette, and you can switch from unfiltered sensors to color filter array. And this is basically how a typical chip looks. Now, they don't all look like this. This is just the most common scenario. Notice right here it says common. And then Bayer pattern. This is the kind of pattern that we're seeing right here. And it favors green. Now, what in the world do I mean by that? Well, these little sensors, the filters that are on the sensors, and the filters are just sort of little droplets of clear resin, essentially, that are on these individual sensors, are arranged in groups of 4 where a Bayer pattern is concerned. They're arranged in groups of 4, and out of those 4, 2 are filtered green, 1's filtered red, and 1's filtered blue. So we've got 1 red, 1 blue, and 2 green. And the reason is because our vision, our system of vision, also tends to favor green. Not quite to this extent, but it does favor green. And green also tends to be where we gather the most detail in terms of, once again, how we perceive color. So what's really happening is this is still just luminance information that's being captured by the digital camera, but for 1 pixel, it's filtered green, so this is capturing the green information for that 1 pixel. That's all it's capturing, just green information. And this pixel is just capturing blue information, and this one just red information, and this one just green information. And that is the raw data. So basically, if you were to look at a string of, the code, the actual code that is a raw camera file, if you were to dissect it and take a look at it on a mathematical level, you would just see a bunch of numbers that are indicating the luminance information. And that's associated with either a green filter, a blue filter, or a red filter. And that's all it gets. So how in the world does it get from being this kind of information right here, where you only have luminance data that's filtered, so you only have 1 out of every 3 colors per every pixel, 1 out of every 3 color channels, that is. How do we get from this to the full color raw image, which is what you see right away inside the Camera Raw interface? I will explain that in the very next exercise.